Yes, this is lesson 4. Yes, question. Let's do this. Let's review this, and then we'll get on to lesson 4 notes here. We got a hexagon, a dodecagon. We got a trapezoid, a rhombus, a rectangle, a square. Kylie. Yeah. You want to get up there and do them? Sweet, do it. Kylie's going to tell us. Sure, you can do as many as you want. As many as you want. You don't have to do all of them. That's okay. Give it a shot. Kylie says hexagon is a 6-sided polygon. 12-sided polygon. So far, 2 for 2. Trapezoid is... Oh. So can we help her? It's not A. What is it? It's B. Yep. Just kind of swing that line. Yep. It's okay. Swing that line right over there to B. Good. That's quadrilateral with 1 pair of parallel sides. Good. Rhombus. Ooh. Rhombus. Rhombus has equal what? Sides. Right? So it's an equal. You're okay. You're okay. Just keep that track. Keep that track. Keep that track. Go up to A. Yes. Equilateral, quadrilateral. Got them flip-flop. That's okay. Rectangle is equiangular. Good. And the square is the golden child. Regular. Perfect. Thanks, Kylie. You're 4 for 6. That's pretty good. Our new lesson here. Let's talk about regular versus non-regular. I just want to talk about this. I was going to have you do it, but because of all my talk about, this other stuff, we've kind of run out of time. What would be true about A, B, C, D, and E on the left side? What's true about those values? Yes, Johnny. Equal, right? Would you agree that A, B, C, D, and E would be equal? Good. Now the interior angles would also be equal. And I just know because I do this a lot, that in a regular pentagon, the interior angles are all 108. So what does that make A, B, C, D, and E? 72, right? That makes each of those 72. And so do the rest of them. Well, there's 5 of them, right? So if there's 5 of them, they're all 72. If I multiply 72 times 5, guess what I get? 360. Okay, so now let's go over here to this other side. I want to look at these. Okay, they're not all the same anymore. They're not all the same anymore. But the cool thing about this, and I'm not going to add them all up here, the cool thing about K, H, G, F, and L is they'll still all add up to 360 degrees. Okay, regardless of the measurements of the inside. Okay. L, I don't know, F plus G plus H plus K plus L will add up to 360, just like it did over here at this regular pentagon. And you know what? It's true for any shape. So any polygon, regardless of the number of sides, the exterior angles, these are all exterior angles, they will add to 360. All right, so from what we saw yesterday, the sum of the interior angles of any polygon we had to do a formula for, right? N minus 2 times 180. To find a single interior angle measure, we did N minus 2 times 180 and divided by the number by N. What did N represent? The number of sides, right? Or angles, either way, same thing. Today, our formulas are actually quite simple. The sum of the exterior angles never changes. It's always 360. And a single exterior angle, if it is a regular polygon, is just 360 divided by N. So yesterday we had a formula, then we had a formula divided by N. Today we have a number, and a number divided by N. Cool. Let's continue. So let's try this example together, and then we'll move on to another one. Find out how many sides a regular polygon has if each exterior angle is 36. So each exterior angle. What does the word each imply? Say it. One of them, right? One of them. Well, one exterior angle has this formula. Right? So if I take 360 divided by the number of sides, I should get the measure of one of those exterior angles. Well, 360 divided by what gives me 36? 10. Yeah. So this is a decagon, has 10 sides. Okay, how many sides in a regular polygon if each interior angle is 168? Okay, each interior angle is 168. Okay, so now we're talking interior. No, I didn't like that. Let's do this. N minus 2 times 180, or n minus 2 times 180 divided by n. Which of those two formulas do I want to use here? Yeah, cool. Second one, because of the word each again. The word each again. Okay, I'd like for you and your neighbor to work out the number of sides for this regular polygon. Okay. Key to this problem, set it equal to 168, and I'd like you to solve. Okay. Looking at Aaron's work, we get 168 equals n minus 2 times 180 over n, multiply by n on both sides right here. Okay, so we get 168n equals n minus 2 times 180. She distributes to the next step, subtracts 168, comes out with 0 equals 12n minus 360, adds the 360 to the other side, and divides by 12. Let's see if she's right. Yeah, 30 sides. Good job. Nice work. Okay. Awesome. I would like to skip ahead to this one and just have a conversation. Let me see what's on the next slide. Yeah, just homework. Okay, I'd like to skip ahead to this problem, which obviously is the third example. And I want to talk through this real quick. All right. What are the first things that should go through your mind here on this problem? Read. Is it? Thank you for the heads up. This is on your homework. We're about to do your homework. Spencer's like, get more chicken strip stickers, would you? Okay, so what do you do? What's the thought here? Yeah, read. Okay, so all of them, right? So we got a quadrilateral down here on the right, quadrilateral up here, and then we got a seven-sided polygon. So a seven-sided polygon has, oh boy, n minus 2 times 180. So that's 5 times 180, which is 900. Well, this is the one that comes out to be a decimal, right? So I take 900 and I divide it by 7, and I get like 128.57 degrees. Something weird like that, right? So it looks like our answer is going to be a decimal, but I get 128.7 here. 57. That's a weird 5, but kind of looks like Dracula wrote it. 57 and 128.57. And I'm looking for the measure of angle C and the measure of angle D. Okay, so what's true about 128.57 and C? Good. They add up to 180. Boom. Okay, it looks like I rounded this to 128.6, so that came out to be 51.4. Okay, so I had in my key done this, right, 128.6. Okay, so C is 51.4. And then what's true about these two angles? They're equal. Now what's true about those two angles and 128.6? They add to 360. So I could solve for D by taking 128.6 plus 2D and setting it equal to 360. Good. You got it. It looks like your answer should come out to be 115.7. Okay, now I think I might give you some grace on how you enter that into Schoology, whether it's one decimal or two. Okay, so just be mindful of that your answer, if you go to two decimals, is going to be a little bit different, which is fine. Okay, but that's the process. The process is identify polygon sides and work from there.